The radius of a conical tank is 1.7 meters and the height of the tank is 1.7 meters. Water is flowing into the tank at a constant rate of 58.3 meters cubed per minute. At the instant the depth of the water is 0.5 meters, answer the following. At what rate is the depth of the water changing? So we have to find the change in height over change in time when the height is 0.5 meters, and we know that the change in volume over change in time is 58.3 meters cubed per minute. So we take our volume equation of a cone, 1/3 pi r squared h, and we know that the volume of the water is proportionate to the total volume of the cone, so r over h is equal to 1.7 over 1.7, which would mean that r is equal to h. And now we substitute h for r in our volume equation to find that volume equals 1/3 pi h cubed. And we find the derivative of that to find that change in volume over change in time is equal to pi h squared times change in height over change in time. And now we plug in our values to find the change in height over change in time, and we find that the depth of the water is changing at a rate of 74.23 meters per minute when the depth is 0.5 meters. And for B, we have to find the radius of the water's surface is changing when the depth of the water is 0.5 meters. And to do that, we have to find the change in the radius over change in time when the height is 0.5 meters. To do this, we take our volume equation once again, 1/3 pi r squared times height, but this time we substitute height with radius, so we find that volume is equal to 1/3 pi r cubed. And then we find the derivative of that, which is change in volume over change in time is equal to pi r squared times change in radius over change in time. And now we substitute our values and find that the radius of the surface of the water is increasing at a rate of 74.23 meters per minute when the depth is 0.5 meters.